Oh, hello there. My name is Lucas Muya from Tanzania, and I study at the African Leadership Academy in Johannesburg, South Africa.
Have you ever thought of using charcoal as a source of electricity?
Are we talking about the coal power plant?
Yes, the same charcoal that you use in your Sunday barbecue. No, we're not talking about the coal power plant. That's a completely different story. To begin with, we have to differentiate charcoal and coal. Coal is a fossil fuel created by altered remains of prehistoric vegetation originally accumulated in swamps. Charcoal, on the other hand, is a porous black solid consisting of an amorphous form of carbon. It is obtained as a residue when mainly wood is burnt in the absence of air, a process which takes 3 days. According to the International Energy Agency, out of the 1.111 billion people living on the African continent, two-thirds have no electricity, and the remaining one-third suffer from load shedding. Mom, hamna umeme.
Haya, njoo chukue hela uende dukani ukanunue mishumaa.
Haya, nitaenda namalizia kuchukua hii video. For those who are not familiar with the term load shedding is the deliberate shutdown of electric power in part or parts of a power distribution system, generally to prevent a failure of the entire system when the demand strains the capacity of the system. Therefore, the African continent needs an increasing access to alternative energy resources to produce electricity for a faster social and economic development. This is where my idea of a charcoal panel comes about. A source of energy that will act as an adequate source, one that is cheaper than an ordinary solar panel, both in production and price. It will be more convenient then for the two-thirds of the population without electricity to gain access to energy.
I thought about this idea when I realized that we make a common assumption that charcoal is 100% carbon. Now this assumption is flawed, as charcoal, depending on the type of wood, consists of 50 up to 95% carbon. The percentage is assumed to contain fixed or pure carbon bonds. Now the large question then comes, what is on the other 50% to 5% of charcoal? Due to the significant reduced amount of carbon as the wood is being burnt in the process of making charcoal, the ratio of other elements to carbon is largely increased. Therefore, there is a probability that these elements make charcoal a better electricity conductor. The charcoal panel works behind two basic concepts: ionizing radiation and heat radiation. For a clear image of the process, we have to first define radiation. Radiation is the emission of energy in the form of moving waves or streams of particles. This energy can either be low level, like those transferred by microwaves and radio waves, or high level, like X-rays and cosmic rays. Ionization energy is the energy required to remove 1 mole of electrons from its outermost shell. Ionizing radiation is a radiation consisting of particles, X-rays, or gamma rays, with sufficient energy to cause ionization in the medium through which it passes. The particle category consists of mainly alpha and beta particles. The cosmic rays consist of high-energy particles arriving from outer space. These particles are mainly 89% proton nuclei of hydrogen, 10% nuclei of helium, and 1% heavier nuclei. A large percentage of the cosmic rays are deflected by the Earth's electromagnetic field as they approach it, as you can see on this diagram. Imagine these lines as the Earth's electromagnetic field, and these red, blue, and black particles as cosmic ray particles. Now, as the particle approach Earth, they are deflected by the Earth's electromagnetic field. As you can see here, I drew a couple of particles that reach the Earth, but most of these particles actually ionize the air molecules that they meet at the uppermost atmosphere. This means only a minute number of the real quantity of the cosmic rays actually reach us on Earth. As mentioned earlier, when an atom loses an electron, it becomes a positive ion. Now, I assume that the sun can be then able to produce energy to release these electrons from the 50% to 5% of elements. This energy can be absorbed by the charcoal, and hopefully, due to the unknown percentage, the charcoal may then be capable of conducting electricity. Now, this electricity will be harnessed by two metals. What we're aiming at is looking for the potential difference between the two metals, which can then produce electricity. As charcoal also has the ability to absorb moisture, it is then safe to assume that the absorbed moisture can interact with the different bonds present in the charcoal to create ions. These ions, when energized by the sun's thermal radiation, may be able to transfer electricity, which can then be harnessed by, once again, the two different metals. According to research, it is unknown clearly how long charcoal can last. The best assumption is that as charcoal is void of sand, clay, and soil particulates that may alter its durability, it is safe to assume that it is once a solar panel is manufactured, it has the capability to last for more than 60 years. Thank you for watching
My pleasure.
video on one of my ideas, which is a charcoal solar panel. Hopefully after this competition I might pursue more of my ideas, and once again, thank you.